Today we are going to cover section 3.3, quadratic equations and inequalities. So take the time to write down your title and your essential question, how do you use quadratic equation to model real-life applications? Paste your cutout and copy example number 1, and we'll start once you're ready. Go ahead and pause it. So solving quadratic equations. So we started to graph quadratic equations on the last chapter, on the last section. And we know that this is a standard equation of a quadratic function, but now we have a equal to 0 instead of being f of x, where a and b and c are real numbers, and once again, we don't want a to be 0, because otherwise, if a is 0, this disappears, and we now have a linear function. So that is a quadratic equation in standard form. There are several methods that you can use to solve a quadratic equation. Very similar to what you saw back in Algebra 1. You saw this back last year in Algebra 2. And now, once again, in PreCalculus. So to solve it, we can graph a function. And we can see where it crosses your x-axis. And we know that those are your solutions or your roots. We can factor it. We can complete the square, just like we did last time. And we complete the square to be able to rewrite it in vertex form. Today we're going to complete the square to solve it. Square root property, or we can use quadratic formula. Now, you always want to make sure that whenever you are solving a quadratic function, you start with this process. See if you can factor first. If not, you can see if you can complete the square. If not, use the quadratic formula. And you will see that using the square root property, you'll be able to see where you need to use that instead of other ways of solving a quadratic equation. But let's start with example number 1. We have 2x squared minus 7x equals negative 6. So therefore, how can I solve for x? First, we're going to try to see if we can factor it. In order to decide to see if we can factor it, we have to make it equal to 0. So therefore, we're going to move my negative 6 to the left and say positive 6. And now that we have a equal to 0, first we want to see if we can take out a common factor. Is there a number that divides 2, 7, and 6? No. So nothing to factor out, so therefore we're just going to use our double parentheses to solve it. And now factors of 2x squared. So the factors of 2x squared are 2x and x. Factors of positive 6, that can be 3 times 2 or 6 and 1. So the method that we're going to be using to factor is what we call trial and error. And you want to get comfortable with this because we'll be using this throughout this entire school year. So let's see, factors of 6 can be 3 and 2 or 6 and 1. Now remember that whenever I multiply my outside numbers and my inside numbers, they should add up to a negative 7. So which one do you guys want to use? Correct, that should be, I need 7, so therefore I'm going to place my 2 in here because that gives me 4, and my 3 in here because that gives me 3. This is a positive. They need to have the same sign, both positives or both negatives. They need to add up to a negative 7, so they both should be negatives. And that gives you negative 4x minus 3x gives you my negative 7x that I need. And now that I factored, what property do I need to use? So what property do I need to use in order to solve it? Correct, my zero product property. My zero product property tells me that if those two are multiplied and they equal to 0, that means that either 2x minus 3 equal to 0 or x minus 2 equal to 0 in order for that to be true. And I'm going to solve, move the 3 to the right, we can say positive 3. Divide by 2 gives me 3 over 2. Move my 2 to the right becomes a positive 2. And those are the solutions. Now, if we go into decimals and we graph it, so I'm going to type it in as a function, so be f of x equals 2x squared minus 7x and plus 6. So notice that I'm going to graph that part. And therefore, if I did it correctly, my x-intercepts are my solutions, which is 1.5 and 2, and that matches my answer, correct? So letter B, let's go and make it equal to 0, because we want to see if we can factor it. If we're not able to factor it, then we have to see if we can complete the square. But let's go and make it equal to 0 first. Move my 5x to the left becomes a negative 5x, so that gives me x squared minus 5, and minus 1 gives me minus 6x. Move my 3 to the left becomes a positive 10 equals 0. And now if I try to factor it, double parenthesis, factors of x squared gives me x and x. Factors of 10 will be 5 and 2, or 10 and 1. So that won't be able to give me a negative 6x. So therefore, this trinomial cannot be factored. And since it cannot be factored, then we are going to see if we can complete the square. So we prefer not to graph it, because that's going to be a lot of work. And that's not what's going to be giving us the correct x-intercepts if we do it manually. Factoring doesn't work in this case, so completing the square. Now completing the square, if you remember, it is best if it's leading coefficient of 1. So therefore, we want to complete the square if there's a leading coefficient of 1 and your b is an even number. If this happened to be a 5, they probably want to use a quadratic formula. But in this case, let's complete the square. To complete the square, I'm going to move my 10 to the right. So therefore, that gives me x squared minus 6x. I'm going to leave some space to complete the square and move my 10 to the right, becomes a negative 10. And what I do on one side, I need to do to the other side. And what number do I need to add on both sides? Remember, it's b divided by 2 squared. So half of negative 6 is negative 3. Squared gives me positive 9. And now I'm going to factor the left-hand side. And this is now a perfect square trinomial. So factors of x squared gives me x and x. Factors of 9 gives me 3 and 3. And they both should be negative. They should always be the same. So therefore, that'll be x minus 3 squared equals, that gives me a negative 1. And now we can solve. I want to get rid of the squares. So therefore, the inverse is to take the square root on both sides. So that gives me x minus 3 equals, the square root of negative 1 is I. But I forgot something. What did I forget? Correct. Every time we take the square root on both sides, we have plus or minus. It can be positive I or negative I. And one last step. Move my 3 to the right, becomes a positive 3. So therefore, x equals 3 plus or minus I. Now your answers can be left in this form, and sometimes in your homework, you'll have to type it in as a set notation. We have two answers. We usually place the small one first. It'll be 3 halves, or 1.5 if they ask you to do it in decimal, comma 2, and you brace. So sometimes you'll see your answer as this. Sometimes we'll have to separate, and there are two complex answers. So therefore, x equals, I'll place my brace, 3 plus I, comma, or 3 minus I. So there are going to be times that you are going to have to type in your answers as a set notation. And now, if I take the time to graph it on decimals, let's go through decimals and just type it in. You can also do it on your graphing calculator, but there's going to be times that I'll be using decimals because it makes it a little bit faster. And if I type it correctly, it might be helpful. Plus 10. So notice that it doesn't cross the x-axis. Whenever it doesn't cross your x-axis, that means that it doesn't have any real solutions. The solutions are imaginary or complex in this case. Example B, C and D. Go ahead and copy them down, and then we can work them out together. So therefore, go and pause it if you need more time. On letter C, so it's already equal to 0. So the first thing that we should try to see if we can factor it. If you have a trinomial, we're going to try to factor it. Factors of 2x squared gives me 2x and x. Factors of 3 can be 1 and 3 or 3 and 1. I need a negative 4. So if I place my 3 here, in my 1, that gives me 6 minus 1 does not give me 4. If I place my 3 here, my 1 here, that doesn't work. So therefore, this cannot be factored. So the question is, do we want to complete the square? Just like we covered last time, we do have an even number for b. But because we'll have to factor it too, then that's going to make it a little more challenging. So I usually complete the square only if there's a leading coefficient of 1 and this is an even number. But if you usually have a 2, then we are going to use the quadratic formula instead. So let's use the quadratic formula. Now the question is, do you remember your quadratic formula? So let's go right down on the left. Your quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a, where we have a is 2, b, and c. So go and use the quadratic formula to solve it and see what you get, and we can compare our answers afterwards. Go ahead and pause it. Excellent. So in this case, we have x equals negative b, where b is negative 4, so we can say positive 4, plus or minus square root of b squared minus 4ac, where b is negative 4, a is 2, and c is negative 3, all over 2a, where a is 2. And now we just simplify it. So that gives me x equals 4 plus or minus. This is 16. So that gives me 16. That gives me negative 8 times negative 3. So it'll be 16 plus 24, which will be 40. All over 2a, which is 4. Now I'm going to simplify square root of 40. I can simplify as, correct, square root of 4 times square root of 10. The square root of 4 is 2. So therefore x equals, and I'm going to separate my fractions, 4 over 4 plus 2 square root of 10 over 4. So therefore x equals 1 plus or minus, I'm going to reduce my fraction, so it gives me 1/2. And remember, you cannot reduce the 10, so it gives you square root of 10. And we can separate as a set notation like we did above. And for the homework, you can do it either way. But sometimes on your online homework, you'll have to type it in as this. Letter D. So what should I do to solve it? Correct. At this point, I have a square on the left, so therefore we can just get rid of the square root. So therefore this is using the square root property. I can take the square root on both sides, since it's the inverse of a square. That gives me 2x minus 1 equals the square root of negative 12. We'll have a negative inside, so it gives me the square root of negative 1 times the square root of 4 times the square root of 3. Therefore, that is I, that's 2, and that's square root of 3. So that'll be 2I square root of 3. But I forgot something. Correct, the plus or minus. And now we can just solve for x. Move the 1 to the right, becomes a positive 1. Divide by 2. So when I divide by 2, I'm actually just going to divide each one by 2. So that gives me x equals 1/2 plus or minus. The 2 divided by 2 is 1, so therefore that cancels, gives me I square root of 3. And sometimes you'll see as this, sometimes you'll see as separate and written down as a same notation with 2 different answers. And we can actually take the time to graph it, and that will give you the solutions. So for the first one, that gives you 2x squared minus 4x minus 3. But then notice that every time that you end up with a square root for letter C, that means that your answers will be decimals, correct? Since that's a square root of 10 is an irrational number. But for letter D, they're imaginary solutions, so how will the graph look like? Well, they're complex solutions, correct? So therefore, when I graph this, and the way I'm going to type it in, 2x minus 1 to the power of 2, to the power of 2, and then I'm going to say plus 12. And it should be there. So that means that it doesn't, whenever you end up with complex solutions, that means that it doesn't cross your x-axis. Your answers are not real, they are complex, non-real numbers. So take the time to copy example number 2, and we'll start once you're ready. Go ahead and pause it. Solve by factoring. So factoring is going to be essential in this class. And in order to solve by factoring, we know we need to make it equal to 0. So therefore, I have 10x squared minus 26x. Move the 12 to the left, we can say negative 12 equals 0. Now, many times we are tempted to just, when we have a trinomial, we are tempted to just go through and use our double parentheses. But we need to make sure that we take a step back and we take out the common factor. So one number divides 10, 26, and 12. I can factor a 2. And what's left behind? 2 times 5x squared gives you 10x squared. 2 times negative 13x, and 2 times negative 6. And now that I factor the common factors, the common term, I can factor this out. So go and factor it, see what you get, solve it, and we'll compare our answers. Go and pause it. So the factors of 5x squared will be 5x and x. Factors of 6 can be 6 times 1 or 2 times 3. Now that's a negative 6, so one of them should be negative, the other one should be positive. And they need to be adding to negative 13, so therefore I place my 3 in here, because that gives me 15. I'll make that negative 15. My 2 in here gives me positive 2, will give me negative 13. And my 2 comes down. And since they're multiplying, and they're equal to 0, that means that either 2 should be equal to 0, 5x plus 2 should be equal to 0, or x minus 3 should be equal to 0. And then we can solve it. 2 is not equal to 0, so that doesn't help. Move the 2 to the right, becomes a positive 2, a negative 2. Divide by 2, x equals negative 2/5. Move the 3 to the right, becomes a positive 3. So therefore, my answers are negative 2/5 and 3. I'm going to write them down as a set notation. So 2 over 5 and 3. Make sure that you always place the smaller number first and the larger afterwards. And now, use decimals to check your answer. So pause it, use decimals, and see if you get those two answers when you graph it. So let's see. If we graph it, there are two ways to check your answers, correct? I can just go through and say my first equation is y equals 10x squared minus 26x. My second equation will be y equals to 12. And the intersections will be my solution. So my x value is 3 and negative 2/5. And remember that if you actually, decimals can actually help you as a calculator. So therefore that is correct. Or if you want, you could have just typed in y equals 10x squared minus 26x. Move the 12 to the right, becomes a negative. And then if you type it in this form, then your x-intercepts are your solutions, whichever you prefer. And they both match. So now, work on example B by yourselves and see what you get. Go ahead and pause it. So for letter B, I want to make it equal to 0. I can either bring everything to the left or everything to the right. In this case, I'm just going to move the 20x to the left. We can say negative 20x, so I'll be negative 24x squared. Move the negative x to the left, we can say positive, so it'll be positive 6x, and that'll be plus 30 equal to 0. Now, sometimes we actually might prefer to move everything, because I usually prefer my x squared to be positive. So if I move my negative x squared to the right, we can say positive. It'll be 24x squared. Move my 5x to the right, we can say negative, so it'll be negative 6x, and my 30 to the right, we can say negative. So those two expressions are the same, whichever you prefer. But I usually prefer to have my x squared be positive, so I prefer this one. But since we started this way, let's just go and finish it off. Take out a common factor before I factor using double parentheses. Number that divides 24, 6, and 30 is 6, but I want to factor in negative 6 because I want my x squared to be positive. So negative 6 times positive 4x squared, and now that's positive. Negative times a negative x, and negative 6 times a negative 5. And now I can have a trinomial. I can use double parentheses to factor this out. Factors of 4x squared can be 2x and 2x, or 4x and x. I'm going to use 4x and x. Factors of 5, 5 and 1. 1 negative, 1 positive, so it'll be a negative and it'll be a positive. And my negative 6 comes down. And now I can use my zero product property because they're multiplying, and all three, when you multiply three numbers equal to 0, that means that either negative 6 equal to 0, which is false, either 4x minus 5 equal to 0, or x plus 1 equal to 0. Move the 5 to the right, we can say positive 5. Divide by 4. Move the 1 to the right, we can say negative 1. And now I'm going to check my solutions. And I can also plug them in if I need to, but for today, we are going to use decimals. And I'm just going to use the intersection. So therefore, to see if it's correct. And that should be y equals. That's my first equation. My second equation will be y equals 20x squared minus x. And decimals does a good job allowing you to zoom in and move it pretty quickly. So therefore, my intersection is negative 1. And this should be 5/4, which is 1.25. And that's correct. So the x values of the intersection are your solutions. So take the time to copy your cutout and copy example number 3, and we'll continue once you're ready. Go and pause it. So the discriminant is the expression b squared minus 4ac, and that is part of your quadratic formula, correct? Where we have b squared minus 4ac. And we can use its value to determine the number of real solutions of a quadratic equation and the number of x-intercepts. So if b squared minus 4ac, if it's less than 0, which is negative, that means that we have two imaginary solutions, which means that there are no x-intercepts. Just like we covered in the previous example, if it's equal to 0, you have one real solution. And if it's positive, that means that we have two real solutions. That means that we have two x-intercepts. Correct? And we understand that that is correct because whenever we use b squared minus 4ac, that is what goes inside the square root. So therefore, if it's negative, we're going to have an I. If it's equal to 0, that means that there's no more plus or minus. That means that there's only one solution. And if it's positive, that means that we're going to end up with two solutions, one positive and one negative. So therefore, b squared minus 4ac, it's a way to be able to find out the number in the type of solutions, whether imaginary or real. So example number 3, find the number of real solutions. So therefore, we don't want to know what the solutions are. We just need to find the number in the type of solution. So use b squared minus 4ac and see what you get. Going positive. So in this case, you have b squared minus 4ac, where b is negative 4, a is 3, and c is 1. So therefore, that gives me positive 16. Negative 4 times 3 is negative 12, times 1 is negative 12. So therefore, that is 4, which means that this is positive. Remember that this is called your discriminant, and you need to make sure that you remember. Your discriminant is 4, your discriminant is positive, which means that there are two real solutions. And if we actually graph it, I'm just going to use y equals 3x squared minus 4x plus 1, and I can just click on the home to go back to the original. That means that it has two real solutions. Letter B and C. So try letter B and C and see what you get. Going pause it. So first I need to make sure that it's equal to 0, so therefore I have 4x squared minus 3x plus 1 equal to 0. Then I'm going to use b squared minus 4ac. Actually, let's just set it up first. Negative 3 is 4, c is 1. So it gives me 9 minus 16, which is negative 7. That is my discriminant. My discriminant is negative. In this case, it's less than 0, which is negative. So therefore, it has two imaginary solutions. And for letter C, I have x squared to be positive on the right, so therefore I'm going to move everything to the right. So 0 equals x squared becomes a negative 6x plus 9. My discriminant, b squared minus 4ac, where b is negative 6, a is 1, and c is 9. So therefore that gives me 36 minus 36, which is 0. So therefore, if it's 0, we have one real solution. Which means that if, let's go and graph the second one first. If I graph the second one, I'm just going to type it in as plus 1. Notice that there are no real solutions. That means that we have two complex number solutions or two complex solutions. And for the last one, we have x squared minus 6x plus 9. That means that we have one real solution, and we'll talk more about this on chapter 4. Example number 4. Take the time to paste your cutout and copy example number 4, and then we'll continue once you're ready. Go ahead and pause it. So quadratic inequalities in one variable. So a quadratic inequality is an inequality that can be written in the following form. So we have now a quadratic inequality where a, b, and c are real numbers. Once again, a cannot be equal to 0. And notice that it can be any of the inequalities that we have. So take the time to solve letter A and see what you get. Go and pause it. So for letter A, I'm just going to solve it. I'm going to use by square root. So move the 1 to the right, we can say positive 1, or 8, divide by 2, so x squared is greater than 4. Now, how do I get rid of the square? So therefore, there'll be square root on both sides. So therefore, x, and we have plus or minus 2. But the question is, should this be greater than or less than? Because if we place it as greater than, like we have, then x is greater than 2, and x is greater than negative 2, which is not correct. So therefore, whenever we have an inequality, we have to make sure that once we get here, we have to test. We're going to change it first to an equal sign. Then we're going to solve it, so therefore we end up with the same process. X is equal to plus or minus 2. Then we have a choice. We can test a point, so we can make a number line. We can actually take the time to do a number line and say, this is 0, this is negative 2, and this is positive 2. And then we can test a point, because these are the solution. We have this and this as the numbers that we have. We can test a point here, so let's say negative 4, see if it's true or false. We can test 0, and we can test positive 3. But we are actually going to use our graphing calculator, and I'm just going to type in the equation in here. So 2x minus 1, and I'm going to type in y equals to 7. And we have, once again, we have an option. We have the y value, similar to what we covered on chapter 1, where greater than, that means that's going to be this part. The function 2x minus 1 is greater than 7, so therefore it'll be this section here. So it'll be from negative 2 to the left, and this section here, that's where the blue line is greater than the green line, so therefore there'll be this section here. And I prefer to do it that way, but you can also test values. So therefore, according to your graph, is not equal to, so it'll be here to the left, here to the left. And we go right down as a union. So therefore, your solutions will be from negative infinity all the way to negative 2, not including negative 2 since there's no equal sign, and from positive 2 all the way to positive infinity, and there'll be a union. Those are the solutions for the inequality. But you can also test values, just like I mentioned. If you want to know if it's in this side, in the middle, or on the right, you can test a negative 4, plug into your original equation, see if it's a true statement, and test it 0, and test it positive. And if I had done that, if you want to do it that way, then you can do that as well. Plug in a negative 4, so it'll be 2x squared minus 1 is greater than 7. I'm going to test negative 4. That gives me 16 times 2 is 32 minus 1 Is that greater than 7? Correct. That means that your solutions are in this section. Plug in 0. So I'm going to test 0. So it'll be 2 times 0 squared minus 1 is greater than 7. That gives you 0. Is negative 1 greater than 7? No. So therefore we know that it's in this section. We know that it's 9 in the middle section. And then we just test positive 3, any point on the right. So therefore it'll be 2x squared minus 1 is greater than 7. Plug in a 3, that gives me 9, 18 minus 1 is that greater than 7? Correct. So therefore my solutions are also in that section. So that's the algebraic way of testing it. For now we can use a graphing calculator or Desmos to find the solutions. Either way is fine. So now let's work through letter B. First I'm going to change it to an equal sign. X squared minus x minus 12 is greater than equal to 0. And then I'm going to solve it. I'm going to see if I can factor it. X and x, factors of 12, 3 and 4, 6 and 2, so it'll be 3 and 4, 1 negative, 1 positive. Therefore, x equals negative 3 and x equal to positive 4. And now you have an option. Do you prefer to do algebraically or graphically? I know that my solution is 0, 1, 2, 3, 4, and negative 3. So it can be this section here, and the one on the right, or it can be the one in the middle. Well, I know it's going to be greater than, there's no equal sign, so I know that it has to be here. So let me just do it graphically. I'm going to go into Desmos, and I'm going to type in my equation, which is x squared minus x minus 12. And the second one is just y equal to 0. So therefore, when is it greater than 0? It's this section here and that section there. Correct? So that should be on the left. So therefore, once again, it's an OR. So it'll be union. Will be from negative infinity all the way to negative 3. 9 including negative 3. Union from 4 all the way to positive infinity. Try letter C. So take the time to copy your cutout and copy example number 4, and we'll continue once you are ready. Go ahead and pause it. So now we're dealing with a quadratic inequality. It's an inequality that can be written in the following form. So basically we just have a less than, or it can be less than or equal to, greater than or equal to. And once again, A, B, and C, we want them to be real numbers. And A cannot be equal to 0, because otherwise that disappears, and now we have a linear inequality. Now to solve it, looks very simple, right? So take the time to solve it, and then we can talk about it. Go ahead and pause it. So in this case, if we want to solve it, I can just go through the process, move my 1 to the right, becomes a positive 1. That gives me 2x squared is greater than 8. Divide by 2, x squared is greater than 4. And now what will be the next step? Correct. Take the square root on both sides. So therefore x is greater than 2, and let me not forget my plus or minus. And if you write down the two solutions, therefore we end up with x is greater than 2 and x is greater than negative 2. And if we take the time to graph it underneath our solutions, I'm going to place a number line. I'm going to place my 0 center, negative 2 on the left, and positive 2 on the right. So therefore 2 is going to be open, and all the numbers that are greater than 2 are to the right. and negative 2 is going to be open, and all the numbers that are greater than 2 are also to the right. So this is not correct. Now, when we have a inequality, what we actually need to do, we actually need to take the time, if we're going to solve 2x squared minus 1 is greater than 7, we need to take the time to make it into an equal sign. So actually, I'm going to have 2x squared minus 1 equals 7. I'm going to solve for x, same process. 2x squared equals 8, divide by 2, x squared equals to 4. Take the square root, x equals 2, but let me not forget my plus or minus. And now that I have my solutions, I'm going to take the time to graph it once again. And for the first time, I'm going to do it algebraically. So you want to be able to do this graphically, algebraically, and then we can talk about it and see how we can just do it graphically, even if you don't have a graphing calculator. So in this case, it's greater than, it's not equal. So once again, we know that they both are open. And your solutions will be either going away or inside, either in or in and. Same thing as when we did absolute value inequalities. Now, to be able to decide whether this section is part of the solutions, I need to check a number on that side. So therefore, I'm going to check -4. If -4 is part of the solutions, then all those numbers to the left. And let's just do it. It's a pretty quick process. -4. So therefore, 2x squared minus 1 is greater than 7. I'm going to plug in a -4. That gives me 16 times 2 is 32 minus 1 is 31. Is it greater than 7? Correct. So therefore, your solutions are on the left. Now, I want to see if my solutions are in the middle. So therefore, I'm going to select a point to check. So I'm going to check 0, or a value in this case. I'm going to check 0. Once again, it will be 2 times 0 minus 1 is greater than 7. Plug in a 0. This becomes 0. So therefore, I have -1 is it greater than 7? False. So therefore, my solutions are 9 in this section here. I want to see if my solutions are on the right. So therefore, I'm going to check any number. I'm going to check 3. So therefore, that'll be 2 squared minus 1 is greater than 7. I'm going to plug in a 3. That gives me 9 times 2 is 18. Minus 1 is greater than 7. 17 is greater than 7. And that is correct. That is true. So therefore, your solutions are also on this side. Very similar to when you guys graph inequalities. Now, I prefer to just check it graphically. So therefore, I'm going to check it the same way that we were checking before. I'm going to say y equals 2x squared minus 1 and y equal to 7. So this takes us back to the first chapters. So these are the intersections, and for this function, for it to be greater, it's going to be on this side. So it'll be all the values of greater than -2. And on this section here is greater than 7 than the other function. So therefore, that will take us to that part. And therefore, my solutions are this section here and here. Now, another way that you can think about is that we have a parabola. So if you just want to be able to think about a parabola in greater than 7, so it'll be that part, this part here, and this part here. Correct? So let's go through letter B. So, well, actually, let me go back because I do need to be able to write my solutions as an interval. So therefore, my solution, and I'll write down here. It'll be from negative infinity all the way down to negative 2. And negative 2, it's open, so it gets a parenthesis. Union, my solutions are also from 2 all the way to positive infinity. So back to what we did on the first chapter. So that is my answer for letter A. So for letter B, so let's go through the process. Go and write it down, and we'll continue once you're ready. Go and pause it. We have it already is 0, so therefore I'm just going to place it into an equal sign. So x squared minus x minus 12 equal to 0. I'm going to factor it. So factors of x squared will be x and x. Factors of 12 will give me 3 and 4, 1 negative, 1 positive. So that'll be a negative 4 and a positive 3, correct? Now, because they're multiplying and they equal to 0, I'm going to use my zero product property. So x plus 3 equal to 0, x minus 4 equal to 0. Move my 3 to the right, becomes a negative 3. Move my 4 to the right, becomes a positive 4. I'm going to use a number line. And I'll place my 0 here. Negative 3 is on the left, and 1, 2, 3, 4 is on the right. It's also greater than, there's no equal, so I know it's going to be open. Now, if I think about my problem will be going through those 2 points, and the numbers that are greater are going to be in this side, so that should be going away, correct? Or we can actually take the time to graph it, where we have x squared minus x minus 12, and I have 0. So we have the function that are greater than 0 is this section here, so that'll be from negative infinity all the way to negative 3. And same thing here. So therefore, that'll be this section here, or if you want, you can also check it algebraically. We can test maybe negative 5, 0, and 6. But for now, I also want you guys to kind of get comfortable checking it using decimals, because that's part of your SBAC. But now let's write down your solutions. It will be from negative infinity all the way to negative 3, 9 including negative 3, union from 4 all the way to positive infinity, 9 including 4. Remember, infinity always gets parentheses. So now try letter C. See what you get, go and pause it, and we'll compare our answers afterwards. Excellent. So now, at this point, you have worked it out. I notice that I have my x squared is positive on the right, so therefore I'm going to move everything to the right. So 0 is greater or equal to 2x squared plus 5x and minus 12. And now I'm actually going to make it into an equal sign. So I have 0 is equal to 2x squared plus 5x minus 12. And I'm going to factor it out. There's nothing to factor out, no common factor, so I can just use my double parentheses. Factors of 2x squared will be 2x and x. Factors of 12 can be 6 and 2, 3 and 4, 12 and 1. And 5, so I'm going to use my 4 because that gives me 8, and my 3. That gives me positive and negative. And now, because they're multiplying and they equal to 0, either 2x minus 3 equals 0 or x plus 4 equal to 0. And I can solve each one. So therefore, x equal to 3 over 2, 1.5, or x equal to negative 4. I'm going to use my number line. Negative 4, so I'll put my 0 here. Negative 4 is here. 1.5 is 3 halves here. There's an equal sign underneath, so I know it's going to be close on both, because it can also be equal to. Now, if I think about this inequality, this is less than 0. So this is a positive. So if I look at the parabola, all the ones that are less than 0 are going to be on the bottom part. So that should be the intersection between both. Correct? But if actually I look, if I go back into my decimals and type in, I'm actually going to type in my original function, which is negative 5x plus 12. And I'll do it both ways. And 2x squared. Let me zoom out. So therefore, the points where negative 5x, one way of thinking about it, just like we covered on the last chapter. Another way to think about it is just type in your 2x squared uh, plus 5x minus 12, and this will be 0. So therefore, where is 0 is greater than, or the function is less than, it's also in between. That's that section right here. So therefore, my solution are all the points from negative 4 all the way down to 3 halves, where negative 4 is part of it because of the equal sign, and 3 halves is also part of it. So this is my answer. So two last word problems. So take the time to copy example number 5, and we'll start once you are ready, or paste it. Go and pause it. So now we're going to go through two applications. On the last section we did one of them, which was when you throw an object, what goes up must come down. Now in this one, Mike has a painting with dimensions of 19 times 20 inches. He would like to frame it with the same frame width throughout the painting. What is the width of the frame if he needs the final product to have an area of 420 square inches? So this is a typical SAT question. So let's make a quick drawing. Mike has a painting with dimensions of 19 by 20, so almost square. So I'm just going to use 2, 4, 5, and I'll use 6, 2, 4, 6. Doesn't have to be accurate, but it helps to be. So this will be 19 by 20. And he wants to place a frame where it's going to be the same width. So let's just go and make the frame 1 square all around. So we need to be able to find what is the width. So we need to be able to find this width, which should be the same as this width, right? Because he wants it the same. And he wants the area to be 420. So therefore, we need to find this. So we're going to place this as x. This will be x. This will be the same width. And this will be the same width. So now, we need to be able to come up with the area. We know that the area would be 420 for the larger, correct? So therefore, what is the formula for the area? Area is equal to length times width. So we know the area of the entire picture with the frame will be 420. That's what we're looking for. Now, what is the length? So therefore, the length will be from here to here. Do you agree? Or basically just from here to here. So I know that this section is 19, and we have two x's, so it'll be 19 plus 2x, or 2x plus 19. Now the width, this is going to be the width or the outside. So therefore this is 20 plus 2x or 2x plus 20. So this is a very typical SAT questions that you guys will see when you take your SAT. If you take your SAT nowadays, right? And now I can solve it. So go and multiply it out, make it equal to 0, and see what you get. Go and pause it. So therefore I'll multiply this out, so I have 420 equals 2x times 2x is 4x squared. That gives me 40 plus 38, let me just write it down, plus 40x plus 38x, and 19 times 20 will be, twice as 19 will be 380. I'm going to combine like terms, and I'm going to move my 420 to the right so I can make it equal to 0. Well, let me just do it in 2 steps. So now that I simplified the right-hand side, I notice I have a quadratic equation, so now we just need to solve it. Make it equal to 0, minus 420 on both sides, so I have 0 equals 4x squared plus 78x minus 40. And now we should be able to factor, right? If you haven't done so, go and pause it, factor and solve it and see what you get. So once again, before we actually use the double parentheses, we need to make sure that we take out the common factor. Number divides 4, 40, that'll be 4, but half of 78 is 39, so we can only factor a 2. That'll give us 2x squared plus 39x minus 20. I'm going to factor this out. If I can't factor, then I have to use the quadratic formula. But this should factor nicely. 20, I'm going to place my 20 times 1, because that gives me 40 minus 1. So it'll be positive and that'll be negative. And then I have my 2 here, equal to 0. We know that 2 is not equal to 0. Then 2x minus 1 equal to 0, and x plus 20 equal to 0. So therefore x equals 1/2, or x equal to negative 20. Then your measurement cannot be negative, so therefore this is not possible. So the only possible answer will be 1/2. So your frame is equal to 1/2 inch. And we can actually just test it. We know that that'll be 19.5 times 20.5. Well, actually, 1/2 inch and 1/2 inch will be 1 inch. So it'll be 20 by 21. 420. So that works. So therefore, this is now 21, and this is 20. And the last example for today. So another common problem. Go and pause it, copy it down, and we'll start once you are ready. So you have 600 feet of fencing to enclose a rectangular plot that borders a river. If you do not need to fence the side along the river, find the length and the width of the plot that will maximize that area. So therefore, it's always nice to be able to make a quick drawing. So we have a river, and we need to be able to fence. So I'm going to do, we only need to fence 2 sides. We don't know whether this is the longer side or that one. So we don't need to fence this, so therefore we just need to find the sides and this side. We know that those are equal to each other, so I'm going to place this as an x, so therefore I'm going to place this one as an x as well. And this will be a different variable, so it'll be a y. So we are going to enclose it with the 600 feet. So therefore, all three sides will be equal to 600. So we are first going to use our perimeter. And then we need to be able to find the largest area. And then we're going to also calculate the area. So for the perimeter, we know that all three sides, so x plus y, or 2x plus y should be equal to 600. And for the area, we know that the area is equal, we don't know what the area is. We want to be able to maximize it. It will be length times width, which is y times x or x times y. Now in this type of problems, you guys will see this in calculus, and we'll come back to this problem once we go into the last chapter, chapter 13. But for now, I have two equations, and I need to solve for x and for y. So I need to decide to do it by combination or by substitution. By substitution, correct. So therefore, I'm going to solve for y. Move this to the right, we can say negative. So therefore, y equals negative 2x plus 600. And now that I have the value of y, I'm going to plug it in here. And I have the area equal to x. But instead of the x, I'm going to replace it with, excuse me, instead of the y, I'm going to replace it with 2x plus 600. And now we have area equals negative 2x squared plus 600. And now I need to be able to maximize it. To maximize it, basically, I just need to be able to find, well, I forgot an x in here, right? So now what I need to do, I can graph it and find the highest point, which will be the maximum value, or I can find the vertex. So let's go and find the vertex. So in order to be able to find the vertex, what formula do I need to use? Correct. I need to use x equals negative b over 2a. So find the vertex, find your x and your y value, and then we can talk about the answers. Go and pause it. So in this case, it will be negative b, which will be negative 600, all over 2a, where a is negative 2. So therefore, x equals negative 600 divided by negative 4. So therefore, x, 4 half is 300, so it will be 150. So therefore, that is our x value. That will be 150. Now I need to be able to find the y value. So how can I find the y value? Correct. I can just plug it back in. So therefore, y equals negative 2. Instead of the x will be 150 plus 600. Let me just place an arrow so you, and on your notes, you want to make sure that you get used to just writing the arrow so you know where your formulas come from. And that'll be 150. So therefore, y will be equal to negative 300 plus 600. Y will be equal to 300. So let's find the length and the width. So the length is 300 feet, and width is 150 feet with the maximum area of, what's 300 times 150? Will be 3 times 15 is 45, and 3 zeros. 45, 1, 2, 3 square feet. So that will conclude the lesson for today. Have a great day, and I'll see you guys next time.